Good morning. I'm very happy to be here this morning because I get to give a talk about these two. Sorry, not these two, these two. Chrome and DevTools, and how we can combine them to create powerful automated tasks that help us out in web development. So I'll tell you a little bit about me. My name is Yonatan Mevorach. I'm a web developer. I have 2 kids along with my amazing wife, whose name, and I swear this is true, is Git. And I work for Wix.com as part of the WIX engineering team. WIX is one of the leading visual website builders. It's been around for quite some time. Recently, we also started as a platform for small businesses, so it lets you manage your online presence as well as communicate with your customers and manage your inventory and things of that nature. We have an office actually in Lithuania, where we have autonomous teams working on the very cutting edge of what is happening inside the WIX platform. A little bit more about me. I really love automating things. I love taking something that's usually done manually, something that's very tedious, and using code to do it so nobody ever has to perform this task manually again. And I have to admit, I'm guilty of this. Maybe some of you are guilty of this as well. Sometimes I need to perform a task maybe like twice, something very tedious, but I still take the time to write it with code, even though writing it with code will take me much longer than it would ever take me to do it manually. But I just prefer using code to write automated tasks. It's a lot nicer. Another thing that I really enjoy is working with Chrome DevTools. It's really an indispensable tool for any web developer. I think that all web developers agree that it's the best tool for web development. That's not true, of course. Developers don't agree on anything. But if they were ever to agree, maybe it would be on a tool like this one. All right, so let's talk about web automation. The first thing that usually comes to mind when we talk about automation in the web space is this idea of, some people refer to it as end-to-end testing or browser testing. It's the idea that every time you want to implement a new feature, you're extending the UI of your web application. You also take the time to write a test for it. So you use code to describe how the user is going to interact with the application, and then you use code to describe how the UI is supposed to change based on that interaction. And you aggregate all these tests, and every time you want to release a new version to production, you run all these tests, and then you get some notion of if it's ready and stable to ship to production. So this works really well for features that are about extending the UI and creating some new feature, a visual feature. But as web developers, I'm sure you've had a chance to do a feature that's more technical, that's about making your web application faster or more secure or more accessible. And we need to think about how we can test these types of features as well. Ideally, we want to be at a stage where every feature we do, we can write a test for it. So this is something that we're going to focus on today. We're going to see an example later on of, we're going to assume that we just completed this feature that's going to make our site faster, and how we can write a test so that it stays fast over time. But really at the core of the technique that I'm going to show, it really has nothing to do with testing on its own. It's really the ability to automate anything that you do in web development. So where you take this and how you apply this is really up to you and up to your imagination. All right, so when we talk about automating things in the web space, we usually think about using headless browsers. Headless browsers are regular browsers, but instead of controlling them with a mouse and keyboard, you control them with code. And instead of actually displaying something to the real display, there is no real display. They render things in memory, so they're really well suited for testing and automation. Up until recently, the undeniable king of headless browsers was Phantom.js. But today we're going to talk about a new player in this game, and that's Chrome. But not Chrome the way you and I use it every day, but rather Chrome running in headless mode, which is a new capability introduced in Chrome 59. So now the ability to run Chrome as a headless browser is officially supported. Now, along with the headless Chrome, the Google team also released a library called Puppeteer. Puppeteer is a companion library for controlling headless Chrome. And we're going to see an example of using it. It's just a node library. So you can just grab it off NPM and start using it immediately. It takes care of getting and installing Chrome on your behalf. So this is the example that we're going to demo Puppeteer with. We're going to do something that's very common to do, again, with headless browsers and with automation, and that's to extract data from a website. Let's say there's a website that doesn't have a proper API, but we still want to get information from the website. So we want to take the web page which is suitable for a human, but still get that information and get it into our machine, our script. So let's say, for the sake of the example, that we have the FrontCon website, the schedule page, and we want to extract the schedule and get it in a nice consumable JSON format so we can do whatever with it. Let's say, for example, create a smartwatch app for FrontCon. And of course, I had to actually build that once I thought about that idea. But let's take a look at the script for actually reading the schedule and getting it in a nice JSON format from the FrontCon webpage. So the first thing you would do is you would require Puppeteer. Again, it's just a regular node library. Then we're going to call puppeteer.launch, which will take care of launching Headless Chrome for us. Notice that all of the commands that I'm using here start with await, because everything is asynchronous. I need to wait for the Headless Chrome to execute this. So this is the way I'm telling it to wait until the next line. Then I'm going to call browser new page, which is essentially the same as opening up a new tab in my headless browser. And then I can navigate to the FrontCon schedule page. And notice that I'm passing, other than the URL, of course, this extra parameter. What this is telling Puppeteer is to wait until there are no network requests pending. So the way the FrontCon page is built, it's doing client-side rendering, and so by default, if you don't pass in this parameter, it will wait until the page load event is fired, and this is a way to tell it to wait a bit more until there are no network requests, and then you can go on. So what do we do next? We want to actually get that information from the website. So forget about Headless Chrome and forget about Puppeteer for a minute. If we already had the schedule page open up on our desktop and we wanted to get that information as a JSON object, this is what you would probably do. You would open up DevTools, maybe use the Elements panel to understand the structure of the FrontCon page. You would see that all of the items in the schedule have this class of schedule item. Then you would go to the console panel, and you would type in a bit of client-side DOM code like this. This is just vanilla DOM traversing, so you're finding all of the schedule items, and for each one you're grabbing the time and the event elements, grabbing their text, and all of this will evaluate to exactly the JSON that we need. So how do we get this done inside Puppeteer, inside of our node script, which is controlling Headless Chrome? Well, we can do the exact same thing using the page.evaluate method, which takes a function, and this is the exact same function that we saw before. Now this could be a bit confusing because this is part of my node script, but obviously I'm using document and other DOM browser APIs here. So this is not executing here. This is just sent across, executed in the headless browser, evaluated, and the response is sent back to me, made available as part of my node script, and then I can do whatever I want with it, like write it to console or whatever I want. And if I want to be a good boy, I then close the browser as well. So that's Puppeteer. If you like using Docker, you should know that Headless Chrome works really well with Docker. And if you like the idea of using a headless browser, but for some reason you're not a fan of Chrome, you should know that Firefox also supports Headless Mode as well. But today we're going to focus on Chrome. All right, so now let's talk about Chrome DevTools. Like I said, it's a tool that I really enjoy working with, and I'm sure many of you as well. I'm sure you're familiar with the Elements panel, the Sources panel, all these other tools that DevTools offers. But if you haven't had a chance to recently go over all of the different options that they support, they've been adding a few different new panels over the past few years, especially along this bottom section here. So you should check it out. Maybe there's a new capability that you weren't aware of where it's solving something that's relevant for you. Now, what's interesting to note about DevTools is that even though it's got that gray background and it looks just like a regular part of Chrome, DevTools is actually written with a different technology stack. So it's actually a single-page application written with web technologies, so JavaScript, HTML, CSS. That means that as a web developer, if you were to go and read the source code of DevTools, which of course you can do because it's an open source project, you would find it fairly readable and understandable. Now what this also means, though, as a web developer, is that because it's just a UI, it's just a single-page application, the information about the page that you're inspecting has to come from somewhere else. It can't figure out on itself what are the elements on the page and what are the network requests and etc. So in order to get that information, the DevTools frontend or the DevTools UI communicates with Chrome as a backend, and that's the way it's able to get that information. And we call this the DevTools protocol. It's the communication protocol between the DevTools frontend and Chrome itself. So we're going to see an example right now. Let's say that you open up again your DevTools console and you type in just 1 + 1. So what the frontend will do, the DevTools frontend will do, is it will compose this message, a runtime.evaluate message with 1 + 1 being the expression. It would send this across to Chrome, where Chrome will execute this. Chrome will calculate this very difficult mathematical problem and will return the response. And this will be accepted by the DevTools frontend, and it will display this. Now, this protocol is not some secret implementation detail. It's fairly well documented. There's a website for it. You're welcome to check it out and learn more about it. Now, another neat thing about having this very clean separation between the DevTools client and the DevTools target or the Chrome, other than having like separation of concerns, is that you can actually swap one of these out, and the other entity won't know that anything changed as long as what's being sent across is valid DevTools protocol commands. And this sounds kind of like it has no real benefit, but in fact this is very useful. So for example, up until a few years ago, the debugging experience for Node.js was pretty bad. But the Node.js team saw what a great debugging experience there exists for client-side applications in using DevTools. So what they did is they re-implemented parts of the DevTools protocol inside of the Node process. And by doing that, they were able to completely reutilize and reuse the DevTools UI that exists for client-side applications. So in order to play with this, all you have to do is start a Node script the way you normally do, but you pass in this extra parameter of --inspect, and what you'll get is the familiar DevTools UI, but for debugging your server-side application right now. And you know, they didn't stop there. They also said, you know, DevTools has great performance profiling capabilities. So again, just by re-implementing parts of what Chrome usually does inside of Node, they were able to get some of the client-side profiling capabilities. So for example, if you're not familiar with this, this is called a flame chart. It's a nice visual way to see and understand the performance bottlenecks of your application. So each one of these bars represents a function call in your Node script, and the longer the bar is, the longer it takes to execute. And it was already available for client-side, now it's available for server-side as well. But it's not just the Node team. Today you can debug iOS applications, you can debug Android applications, you can even, if you want, debug Internet Explorer applications using the familiar DevTools UI. All right, so we mentioned Puppeteer earlier, and we said it's a high-level wrapper for controlling Headless Chrome, but we didn't really say how it's able to communicate and control Headless Chrome. So by now it should be clear that it's doing that on top of the DevTools protocol as well. So all Puppeteer is a library that's able to send and receive DevTools protocol commands. And the same is true for Chrome Driver, the project that's been around for quite a few years for controlling regular Chrome from Selenium, also based on top of the DevTools protocol. So the takeaway here is this: if you want to create powerful automated tasks, if you want to play with headless browsers and extend the capabilities, being familiar with and being comfortable with the DevTools protocol can really help you go a long way. So we're going to see an example of that in a minute, but first let's just see how you would even launch Headless Chrome. So first you need to find the Chrome executable on your machine. Obviously this is different based on your operating system. Then you need to pass in the headless flag. You need to specify the remote debugging port. This is a port over which you're going to be sending and receiving DevTools protocol commands. And you can also specify the first URL to load as soon as the headless browser launches. Obviously later you can navigate away to different websites using DevTools protocol commands, but this is just a nice handy way to get started with this website right away. So let's see this in action. I'm going to run this. And I don't know what you expected to see, but basically nothing happens, right? Because it's a headless browser. But what I can do is this. I'm going to go to that same port over localhost. And you see, I did say that I gave the FrontCon website as part of my arguments. And now it says FrontCon here. I think you can see it, right? It says FrontCon. Now I want you to think what you expect to see when I click this. So if you're thinking you're going to see the FrontCon website, well, that's not it. But if you're thinking DevTools, then yeah, you're correct. Because Headless Chrome is waiting for DevTools protocol commands, it's also exposing the DevTools UI. But this browser that I'm using here is not Headless Chrome. This is just a regular browser that I'm using. It's exposing the DevTools UI, which I can use to control and see what is happening inside of Headless Chrome. What's unique here is that because I'm inspecting a remote application that's not running on this browser, I have this extra toggle screencast button here, and I can actually see what is rendered in memory by Headless Chrome. I can scroll, I can click things, but everything I do here is just serialized as a command that's sent across to Headless Chrome, and I'm getting a live preview back of what it is seeing. So that's Headless Chrome. Now let's talk a bit about how we can utilize this and the type of things that we can solve by using the DevTools protocol. So the example that we're going to demonstrate this is this one. Let's say that I have a website that I want to make it faster, and I take the time to get rid of all of the unused CSS in my application. So just to make sure that we're all synced, obviously the style sheets that I send down to the client impact the performance. It takes time to load and parse and all that. So if the selectors that I'm mentioning inside of my CSS are never used at any point inside my application, then it's a net loss for the user. He's not benefiting from it in any way. So ideally, we want to send down only CSS selectors for elements that will be available in some point in our application. So now let's take the time to assume that I take the time to actually get rid of this. I do cleaning. I say, okay, we used to use Bootstrap a lot, and we're still sending it down to the client. We hardly ever really use it. So now I'm going to get rid of all of that. I could stop there, but it would be more interesting if I write a test for it to make sure that if somebody reverts what I did, if somebody deletes a big feature without deleting all of the relevant CSS for it, then I would immediately get a continuous integration server to break, the build to break, maybe get a Slack message, an email, whatever, as long as I know about it immediately and catch it early on. So let's see how we can achieve that. So the first step in realizing that this is possible is realizing that Chrome already has the ability, or sorry, DevTools has the ability to give you information about how much of my CSS is unused. So to demonstrate this, I want to navigate to a different website for a conference which I'm launching next year to compete with FrontCon. As you can see, it has an amazing website. And this is a panel that I'm not sure how many people are familiar with it. This is the coverage panel inside of DevTools. And what this lets me do is I click this Start Recording button, and immediately it will tell me that 54% of my CSS is unused. This is a pretty large number, right? More than half of the CSS that I'm sending down is not really used. But this is not the real number, because all I did was load this amazing website. As I click the things and I do actions that the user would take in my application, you can see that this number starts to go down, and eventually it settles after I did all the things that I can do in this particular website at 14%. So ideally, this is the number that I want to get in an automated manner. I want to set this as some sort of threshold, and if I cross, let's say, 20%, then give me that immediate alert. So I know that the DevTools UI can provide this ability. I know that everything that's available inside of the DevTools UI is available on top of the DevTools protocol. So all I have to do is I have to figure out what are the DevTools protocol commands that are being sent across when I start and stop the coverage recording. So how can I figure that out? Well, we know that DevTools is just a web application. So we can do whatever we do. We normally want to understand how a web application works, and that's to open up DevTools. So now if I reload everything, I think I mentioned earlier that the DevTools protocol communication is sent across WebSockets. So don't be alarmed. What I have here are two DevTools instances. The one on the right is inspecting the web application on the left, and the web application on the left is inspecting what's happening inside of Headless Chrome. So now if I start and stop the coverage tracking, I can see that the command to start the coverage tracking is css.start rule usage tracking, and the command to stop it is css stop rule usage tracking. Now that I have this information, I can get started with writing my script. So this is our unused CSS reporter. Again, I'm using Puppeteer. I'm launching it and opening up a new tab in my browser. You saw the command I want to send is css.start rule usage tracking. So I need to enable the CSS domain. This is why I have this dom.enable and css.enable commands. The CSS domain is dependent on the DOM domain. This is kind of an implementation detail that you need to be familiar with. If you get this wrong, it'll give you a nice error message. But more importantly, in order to send raw DevTools protocol commands, I'm using the client.send method that's available inside of Puppeteer. So next, I'm going to actually start tracking which CSS style sheets are actually in use. What this will eventually give me is an array of ranges inside of my CSS of selectors that were used. And I said that I want to get this as a ratio, as a percentage between the amount used and the total amount. So in order to get that total amount, I'm going to do something else. I'm going to add an event handler for whenever a new style sheet is added. And that's going to contain the information about what is the size of each style sheet. So I'm going to need that later on. Then I can actually navigate to my website. And in order to get the real data about the real amount of unused CSS, I can also simulate all of the actions that the user is taking. In this case, I'm using the page.click method and clicking on each one of those tabs in my amazing conference website. Then I call stop rule usage tracking, which gives me back the rule usage object. And like I said, that's going to contain the information about the selectors that were used. In order to actually calculate this as a percentage rounded up to the nearest integer, I need to perform a bunch of really simple math operations on the rule usage, which I already have, and the style sheets that I already have. I do this in a function here that I don't show, called calc unused CSS, but trust me, it doesn't do anything interesting. I'll put a link later and you can check out the full implementation, but it just computes this information as a ratio. Then I can write it out. Obviously later I can connect this to something that will really trigger an alert. Let's see this in action. So if I run this and pray to the demo gods, okay, it'll tell me 14% of your CSS is unused. And just to make sure that this is really working, if I comment out these lines that tell it to click on each one of the tabs, and I run it again, it'll now tell me that 54% of the CSS is unused. So it's really working. So just to recap, if you haven't tried it already, start using Headless Chrome and start using Puppeteer. If you're using Selenium and you have maybe like a new project, try to replace it with Puppeteer, see if it's working better for you. If you want to do extract data from websites, try to do it with Puppeteer. If you're working with iOS, Android, Node.js, you want to get that friendly debugging experience that you have with DevTools, you can do that as well. And more importantly, if you're doing a feature like this that is more technical, think about how rewarding it would be to also set up a test like this and then have somebody break it and undo your work down the line, and then he'll get like an immediate email from you with you in CC saying, I see everything that you're doing, I see everything, revert this immediately or else. I put together this page with links on everything related to this talk about getting started with Puppeteer and Headless Chrome, so you're welcome to check it out. And if you have any questions, feel free to catch me now, later. And if you only get tinkering with this and playing with this later over the weekend or next week and you want to reach out, feel free to do it on Twitter. Thank you very much.